Let us invite our second speaker from Taiwan, Mr. Zhou Ye, Executive Assistant to the President of EVP of Elon Microelectronics. Welcome, Mr. Zhou. Mr. Zhou will conduct a comprehensive sharing on human interface of today and tomorrow.
Good morning, everyone.
Good morning.
早安. My name is Joe. I'm from Elon Microelectronics. 大家好，我是义隆电子的 Joe. And want to thank again Mr. Chen, Dr. Chen, Jordan, Tada, and everyone for inviting Elon to be part of this platform, to be part of this journey. Okay. And today I want to spend the next 10 to 15 minutes kind of sharing with everybody from a Taiwanese silicon design house perspective, a solution house. What are some of the opportunities and challenges that we're seeing from moving from a consumer electronic market over to the automotive market, okay? So my title is on human interfaces of today and tomorrow. And human interfaces, you can think of it as simply as the way we interact with machines. The easiest one is everyone has smartphone nowadays. How do we interact? And that's what we're focused on as a company. So for today, as I mentioned, we are one of the biggest suppliers of human interface solutions for the notebook and PC industry, which obviously is very well known within Taiwan, right? Starting from a touch interface. As I mentioned, phones, tablets, notebooks uses very much a touch-friendly interface now. It's very intuitive, and it's just very straightforward. Second one, obviously, is the trackpad solutions. And I'll get to the integration of haptics in a little bit. Third one is for commercial devices, which we like to call the little red dot. Many of you may have used IDBMs or ThinkPads in the past. That's us. So hopefully you had a great experience. If not, then it's probably not us. The fourth one is for biometric. Obviously, we're moving toward a world of passwordless, right? Personalization, customization. So having biometric authentication is very critical. There's two components to biometrics. There's fingerprint recognition, there's facial recognition. So I'll talk a little bit more about facial recognition as we get to automotive. So with this, we can see here, in terms of market share, we're worldwide number one. As I mentioned, what are the challenges and why we really appreciate this platform between Taiwan and Canada is, first, the challenge is how do we move these solutions over to the automotive market? And I'll have some solutions, I'll have some sharing to do in the following slide. That's the first part, right? I think the great part is the interactions right now. As I mentioned, everyone has a smartphone, everyone has a laptop. So we're very much used to these type of human interactions right now. And moving into the automotive market is not going to be too difficult. The second part is supply chain. Last year, we as a company, we sold over 250 million silicons. That's not a small number, 250 million. But out of that 250 million silicons that we sold, less than 1% was in the automotive market. Obviously, there was a big supply shortage from a silicon perspective over the last 12 to 18 months. Now, as I mentioned, the challenge for us is we have the capacity to get silicon, to get priority, to get the wafers, but how do we transition this over to the automotive market to help ramp up as quickly as possible, right? And I think this is where working together with seeing Canada and this platform is a great way for us to kind of make that shift and make that transition. Now, as I mentioned, this is a pretty typical kind of a cockpit, an EV cockpit of today or / tomorrow. A couple key points I want to highlight. Obviously, there's going to be a big, nice, whether it's a rectangular curved display inside the cockpit, right? You see it from all the major big players. This requires, obviously, a display. And for us, we make the chips that power the displays. So we work with companies like AUO, Innolux domestically, and obviously working with some internationally to make a complete solution. So first is the display and the touch. The second portion is, as I mentioned, the touchpad, which supports haptics. When you're driving, the last thing you want to do is take your eyes off the road and look down. So the need for haptic feedback or any type of audio feedback is very critical. We see haptic being the more preferred one, because imagine if you're listening to a song and every time you touch something, it keeps beeping back. So you probably want some sort of a haptic feedback while you're driving. So we see this as the second one. Third one, as I mentioned for biometric, is the need for personalization, right? So right now, there's a big push for kind of rideshare. Rideshare in terms of just maybe my parents, myself, my sister all share the same car. Now, before maybe you have like a key that knows, you have a key that has a certain setting on it. But that requires, if we swap keys, then that becomes a problem. So that, as simply as putting a fingerprint either inside the vehicle to go to your private settings or personal settings, or putting a fingerprint on a card, which is basically is a key for a car. It also adds personalization, also added security. So this way, if you lose the key, no one's going to take your car with that. So these are just things we're thinking about. How do we move from a consumer electronic interface, moving these components and solutions over to the automotive? And this is where I think working with, the automotive makers, the tier ones, are for us is a really big opportunity that we really love to engage in with Canada. And then the second portion I'll talk a little bit more about is more on object recognition, right? The first portion was all about human interfaces. The second part of the human interface will be on object recognition and more driver behavior. So I'll point out a couple things in my later slides about for blind spot detection, backup cameras. That's one portion. The other portion is DMS and CPD. DMS stands for Driver Monitoring System. That can be used for both commercial and consumer. And then CPD stands for Child Presence Detection. Okay. So this is actually, let me go back. Let me play this video again. Sorry. This video it shows an iPad with touch, with a glove on it. You cannot use it on a glove support, but then for our solution you can. So what this is trying to show is that even as a human interface provider, we need to do customizations around glove support and moisture proof, which may not be needed for your smartphone and tablet, but may be needed for the automotive, right? Now, the second portion of the human interface I'd like to share on is on, as I mentioned, object recognition. There's a couple areas of object recognition that we're focused on. First is the front camera, which has to do a lot with the warnings. Lane departure warning, front collision warning, pedestrian warning. That's the first portion. Second portion is on the e-mirror, and I'll talk about that in a little bit with regards to blind spot. The third portion is, everyone's probably pretty familiar with this, is the backup camera. So all these three portions are all outside of the cockpit, but everything gets displayed inside the cockpit, and it all comes together if you combine the DMS as well. So before I talk about each solution and the next steps we're working on, a common question I get is, well, what algorithm is Elan using for these object recognition? Are you designing your own? Are you doing open source? Who are you working with exactly? And what is kind of the benchmark? So I want to just take 1 or 2 slides just to share. So right now, Elan, we have partnered with Zhongying Yuan, which is an Academia Sinica of Taiwan, to come up with the world's fastest and most accurate object recognition. And this covers both YOLO V4 and YOLO R. So this chart basically in summary is this. The higher the MAP number, the better it is, the better the object recognition. This is the left table. The right table is, if you look at it, of that year, using a benchmark of the top 5 object recognition benchmarks, 4 of them was using our model that we collaborated with Academia Sinica on. So this is the foundation of our object recognition AI-based training. And at this page, I also want to thank Dr. Chen, who's here with us today, as he was the former Minister of Science and Technology. He actually congratulated us because there's a three-way partnership between academia, Seneca, Elan, and NTU, National Taiwan University. So we provided the first solution, or the best solution, the most accurate solution, when we were actually able to deploy it inside a traffic light control within for a fisheye camera. So again, we're taking the same type of algorithm philosophy over to the EV market as well. Now, for the front camera, so the front camera, the first step what we're focused on, as I mentioned, is the warning system. This is a real case application where we deploy for Nissan, right? So right now, this is not level 2 or level 3. This is purely on just pure warning. So you can see here, the commercial is actually very interesting. They actually covered up to show that the driver can actually see, and actually you're able to have these warnings pop up inside the cockpit. So this is for the front. This is for the front vision camera. Our next step is taking this camera and adding our AI box to do a couple things. One, to move from object detection to do segmentation. So you can see here, we're able to clearly mark what we call the drivable roads are, right? So we know these are the roads. These are not the roads. You do not want to be driving onto that. That's the first portion. Second portion, we're able to detect multi-lanes within this. And then so you can see here, segmentation with multi-lanes for the vehicle. And lastly, we can detect multiple objects within this. So for us, going from single task to multitask in a unified model. And we call this the lane net when we combine this when we use this unified model approach. So as I mentioned, this is the next step for our front camera using Edge AI. The second part is for the side of the cars. As I talked about before, side of the car, very similar. We will use the same AI box to do the blind side on both sides of the cars. You can see here the red zone. This red portion is the recognition portion. So we only recognize this. This way you don't have too much distractions from others. We're able to recognize bikers, trolleys, and also pedestrians. So these will pop up in what we call an e-mirror, and then these will give you warnings as you approach them. So as I mentioned, you don't want to extend your field of view or your working area too much, otherwise you'll just get nonstop warning popping every other second, which would be very annoying while you're driving. Third part is the backup camera. Again, we can do segmentation to differentiate between this orange area is the actual drivable road, while the gray area is not. And through this, taking a 180 fisheye camera, you can see here we can get a very broad view versus just a traditional camera. One last portion I want to talk on is not only are we focused on sedans, we're also doing taking our platform over to commercial trucks and buses. So one difference is between commercial buses and sedans is that because the truck or the commercial bus is so long, there's an issue of what you call the difference of radius between the inner wheels. So as this truck turns, where the front wheel turns and where the back wheel turns, the turning radius is different. And we need to account for that through our AI model. So let me just share a quick video. So even though we're doing the same blind spot detection on both sedan and taking the same model over to the commercial trucks, we still need to modify it because of what we call the real world problems. Okay. Lastly, what I want to show here is not only can this work in daytime, but also working at nighttime is very critical. You can see here, as car lights approach, we're able to detect it right away at the first spot. Okay. And then the third portion of my sharing is, again, for DMS, driver monitoring system. So we take in the same AI box, and again, we are able to detect a driver's turning, left, right, up, down, and also yawning. Why is this important is that for commercial drivers, it's very critical to track, to make sure they're focused on the road and they're not too tired or playing with their phones or doing other things that may distract them from a safe drive. The next step is what we call AI tracking. This is actually, we actually work with Microsoft. So this is actually me playing a game called Whack-A-Mole with my eyes. So if you played it before, you usually take a hammer and you whack the mole as it pops up. I'm actually whacking a mole purely with my eyes. So that's the next step of doing head tracking over to eye tracking with our driver monitoring system. Now, to kind of summarize, what is Elan doing next, and why do we would love to work with this Canada, the platform Canada has provided, is we're working on the next step of level 2. All the previous slides was on level 1 was level 0. It's all warning system. Now we want to combine our camera solution with radar, what we call sensor fusion, to be able to actually control steering, braking, or accelerator. And then these are just a couple of the applications that we're focused on. So many of you may have cars already have adaptive cruise control, LKA, lane keep assist, and things of this nature. So this is the next part that we're working on right now. And having said that, in my kind of last page, this is a footage of a Tesla crashing into a car on a truck on the highway in Taiwan. So you can see here, this Tesla is allegedly in autopilot mode. You can see the smoke coming out of the tires at the very last second. So what we're trying to point out is, anyone that I drive a Tesla, so the cars are great. Having said that, even with level 2 ADAS, there's still a lot of problems that need to be overcome. So our slogan actually is, so that's why our slogan, I missed it on the last page. There's no best, only better, as seen by this footage here. And from a research we found online, down here, the source, over 50% of the car accidents last year in Taiwan had ADAS installed. So as I mentioned, there needs to be continued improvement in this area. So in summary, for us, for the AI recognition chip inside the cockpit, as I mentioned, we've actually partnered with ARTC of Taiwan and many other companies here locally. And we would be very honored to have the opportunity to work with Canada as they build up their automotive platform and ecosystem. Thank you.
Thank you, Mr. Zhou Ye, for this in-depth sharing.